So in this in this experiment, we facilitating LabVIEW to automating the process of measurement the Peltier device performance. So we need a thermistor, Peltier device, 10 kilo ohm resistor, power supply, and multimeter. So as you can see here in this shot, this is our circuit. This is our circuit. This is the thermistor. It's mounted on the below under the heatsink of Peltier device, and it is connected to 10 kilo ohm resistor, as you can see here. The channel, third channel of our power supply, as you can see, it will provide the 5 volt of the circuit. This Peltier device is supplied from channel 1 of power supply. The fan of our Peltier device, which get the heat through the heatsink, it's provided the voltage, the source, the power from the voltage for the fan of Peltier device provided by channel 2 of Peltier device. So here is our Peltier device, Peltier circuit, and here is the power supply and multimeter for this experiment. As you can see here, this channel, channel 1, provide a voltage for the power for Peltier device. Channel 2 provide the voltage for fan of Peltier device, and this channel 3 of power supply provide the voltage of our circuit. The circuit is very simple, just as I showed you before. Here's our circuit. It's pretty simple. It is just thermistor mounted under the heatsink of Peltier device in series with 10 kilo ohm resistor, and we want to measure the voltage drop across the thermistor based on the increasing the color current of Peltier device, and we measure the temperature based on that, the temperature of heatsink, the cold side of Peltier device, which is here, this side, based on change of current that is supplied by power supply. This channel of multimeter will measure the voltage drop across the thermistor. This is come from the positive side of multimeter, voltmeter, and this is come from the negative side of multimeter. This is the power supply, and this is common ground. So now next we will build the VI, and we will run this experiment so you will see how it measures the temperature characteristic of this device. Now, as you can see here, we coding the experiment and we're building our VI with the LabVIEW. As you can see here, again, in front panel we have 2 fields. First field is dedicating for power supply, and the other field is for multimeter, DM and DS again, as we mentioned in previous experiments. And we set the temperature. For sure you will see what is set temperature in next experiment. The resistance, as you can see here,
it is 10 kilo ohm resistance. We set it as 10 kilo ohm resistance in front panel, and we add the XY graph. So it's gonna plot current draw by the circuit versus the temperature. For designing, for writing the code or building the panel, back panel, we need to define, as you can see, the set temperature, the resistance, and we need to initiating the device. Again, we use the 3-channel of power supply. As you can see here, the first channel is dedicating for providing 12 volt, and second channel also it's for providing 12 volt for the circuit, and the third channel is providing the 5 volt to the circuit, and the second channel providing 12 volt to running the Peltier device itself. Third channel is providing 5 volt for our circuit, and first channel of power supply provide the voltage 12 volt, which is the working voltage of Peltier device. And as you can see here, we have the field for setting the temperature and field for setting the resistance, which we use in our circuit. After this, as you can see here, we need to define a for loop or a while loop, as you can see, as an outer loop, and we use the sequence in sequence. In very first sequence 0, we should actually initiate the power supply and we start the voltage of power. We start the voltage from 0. In each iteration we increase the voltage that's provided by power supply. Actually, we increase the current provided by power supply and supplied by power supply, and this, by increasing the current, we're gonna have the Peltier device make it will decrease the temperature, cause decreasing in the temperature, then decreasing the temperature will gonna sense by thermistor, and we plot that temperature for corresponding current. So in first sequence we will initiating the power supply, we setting the voltage, and that voltage causes specific will supply a specific current to Peltier device. That we, based on that, we waiting for sometimes, as I mentioned here, 20 seconds until the device gets settled. After the device gets settled, the thermistor gets settled, we we measure the temperature, and then that temperature we measure the voltage drop across the thermistor, and we convert it from the relationship that is described on lab manual. We convert it to its equivalent value in degrees Celsius, and we plot the result in XY graph. So as you can see, the third third sequence we will increase the voltage, or actually we increase the current it's provided by Peltier device. And for getting the device stop at a specific point, we should define we should set the temperature. We should define a set temperature, and we define some condition that under that condition, if the temperature get less than or less than the limit or threshold that we define, the while loop can stop and whole program will stop working and plotting our final graph, which represents the performance of our Peltier device. Then here we run the code and we will see the result.
As you can see, based on my setting, it's become constant current. Channel 1, if I go to channel 1, zoom in channel 1, you can see CC versus two other one which they are CV. And here is the voltage reading. As you can see here, the temperature starts from 19 degrees Celsius and is gonna go down more and more by increasing the current. Now, as you can see, we're providing 1.4 amp. As you can see here, the graph, we got the second point. And eventually, as you can see, the temperature went to 13 degrees. We start from 19 degrees Celsius and we end up to about 13 degrees Celsius. now, and we expect to get more and more, decrease the temperature more and more. And as you can see this curve, we start from 19, about 19, and we end up to 12.5. With increasing the current, we got the exponential shape as we expect. So here we are done.